let's start.
Go ahead.
All right, so this is a marathon session. We have 80 minutes to talk. So it's a combination of both introduction and deep dive. So there is no rush. We're gonna cover a lot of things around the SIG. If you have any questions, feel free to ask anytime. We're gonna have a lot of time after presentation as well for discussion, so we can use that time as well. So agenda, pretty simple. We're gonna provide a SIG introduction. I see faces here who probably are not so much familiar with the SIG, so I'm gonna go over the introduction. We'll basically cover the overview, the SIG structure, activities we do, just high levels. And that will be followed by the overview of IBM Cloud, because this is IBM Cloud Special Interest Group. So Khalid will be giving overview of IBM public and private cloud and the hybrid strategy. And that will be followed by a little deep dive with the SIG sub-projects. So we're going to talk about the cluster API, and we're going to talk about IBM Cloud Provider interface. We're going to summarize the talk, and like I said, we're going to have a lot of time for the discussion afterwards. Just quick questions. Are everyone familiar with the concept of SIG? Yeah, everyone knows SIG, right? Yep, perfect. And within SIG, so there are over 30 SIGs. There are a few SIGs are cloud provider SIGs, right? So all the major cloud providers, they have their own SIGs, and IBM Cloud Provider is one of those SIGs. So this SIG is for leveraging Kubernetes on IBM Cloud, public side, private side. How do you configure your Kubernetes to run on IBM Cloud? How do you deploy it? How do you maintain it? And then all that kind of discussions goes under this SIG from the open source side. So on like I said, Khalid will call more detailed, but we have a IKS, IBM Cloud Kubernetes service. That's a public service, and then we have ICP, which is IBM Cloud Private. They both participate in the CNCF certified Kubernetes conformance program, and they both are certified. We stay on top of those certifications. What do you gain as part of the SIG discussions? Is the developers and leaders, in the IBM Cloud space, they participate in the SIG discussions. They share their insight. We discussed so many things about what we're going to be focused on. So all those things follow under the SIG. And then you sort of communicate directly with the IBM Cloud tech leads and the folks involved in the open source side. All right, so the structure. We have 3 co-chairs. This is funny, but this is more like cluster, right? You typically look for 3-node cluster, for high availability, for fault tolerance, whatnot. So 3 leads are good, in case 1 or 2 are not there. At least you have one guy to work with. So we have 3 leads representing 3 different things. We have Khalid Ahmed, who is IBM DE. He represents the ICP side. We have Richard Thies. He is not here. But he represents IBM Cloud Kubernetes Service, and myself, Sahdev, I represent the open source side. There is a link on the GitHub Kubernetes community page. That's where the SIG IBM Cloud is there with a lot of information on it. But there's a charter. We created charter last year. A lot of SIGs now have a charter. And what you get there is the scope of the SIG, like it's not for commercial discussion and other things, and then we follow the SIG governance. Typically, it's same governance all the SIG follows. We have a mailing list, so if you're interested, please join the mailing list to stay up to date on what's going on. And you can learn more about SIG on the README page on the GitHub community site. I should use this one. Alright, activities. The SIG meets every other week. So, it's Wednesday typically at 2 p.m. Eastern time. So it's every other Wednesday we have sort of 1 hour discussions. But that's only the meeting time. We are always on Slack. It's sort of 24 hours. Somebody's, some discussions, some questions, whatnot, right? SIG mailing list is another place to keep connected, share the views, right? All the meetings are recorded. I make sure that every meeting definitely is recorded, and then I try to put it on the YouTube channel, the Kubernetes YouTube channel, just the same day or the next day. So all the videos are there. If you haven't attended previously, just this short link, follow it. You can have like 10, 12 plus videos there. What we do in the meeting, so presentations on various topics, like some of the overviews, the things like upgrade strategy, Kubernetes upgrade strategy in IKS, ICP, anything which comes out, new feature from that perspective. We have somebody from ICP, IKS, from open source side talk about it in the first 10-15 minutes. And it's not just IBM. We have folks like SIG guys. They provided a little talk just 2-3 weeks back. So it's any member interested in giving some overview, they provide it. It's more educational. What else? Quarterly updates to the Kubernetes community. So every quarter, all the SIGs are required to provide updates on the SIG. So we also participate and provide the updates on a quarterly basis. And those are also recorded as part of the bigger Kubernetes community meeting, which is every Thursday, 1 p.m. Eastern. And so those are available to watch as well. Sub-project. So I'm so excited about the SIG. This is a very exciting time. Until now, or I say until 3 weeks back, we did not have any code associated with the SIG itself. So we created the SIG last year. The discussions were mainly around, what we want to do, sort of roadmaps, and like I said, the educational sessions, defining charter and that kind of things. 3 weeks back, we have our first sub project out there on GitHub, Cluster API Cloud IBM Provider. Anybody familiar with Cluster API project? Yeah, couple folks, three, of course. But Cluster API project, I think it's a part of the project under SIG Cluster Lifecycle. So as you know, Kubernetes is getting, high adoption, right? It's just growing, and with that, the requirements from folks are also growing. They're like, oh, I want this, or oh, how about this, right? Or whatnot. But one of the important requirements was about managing the cluster, right? So Kubernetes has a set of APIs to do so many things like your deployment resources, even things like load balancer, right? Ingress, you can have those APIs out there. One thing which is not there, it's out of scope for Kubernetes core, is managing the cluster itself through the APIs, right? How do you manage your cluster? Creating a node, removing it, deleting it, dealing with the life cycle of the node, right? And the cluster. So there was the, that's where the Cluster API project came out. And from the Cluster API, it's a CRDs basically, taking advantage of CRDs. Other IBM and other providers, they have developed their own API provider on top of the Cluster API. Yes, sir.
So the Cluster API provider of IBM Cloud is because essentially the API server is extended via an API, so you need to maintain your API instead of follow the upstream Cluster API.
That's true. It's an extension of the upstream Cluster API.
Okay.
And it has its own repo. And not just IBM Cloud Provider, some of the other cloud providers, they already have their own.
All the CRD, all the extension IBM made are here.
It's exactly.
Okay.
And we have a link coming up, so you can just search for it. But in the one of the following slide has the link for the GitHub repo as well. Yep. This is one of the project we would like to have more contributors contribute there. We already have like 6-7 contributors up there. So many things going on right now. Like I said, we announced it 3 weeks back. So it's still in its early phase. We'd like to have people contribute. This is a good place to contribute. Brad Topol will be talking more about the architecture of the project in the following slides. So I'm not going in detail there. The other thing is support for out-of-tree IBM Cloud Provider. Folks familiar with the in-tree, out-of-tree kind of concept? So just to brief on that, and I'm going to mention the in-tree, out-tree as well. So a few years back, couple years back, some of the early adopters on the provider side, they had their own, provider interface on the Kubernetes core on the master side. So those codes are considered like entry. It's part of the controller manager. So it's sitting there. They've been using it. Eventually, the community figured out that hey, this is not the right way to do this kind of things. This is adding, creating the bigger binaries because all cloud providers have their, AWS, Google, they have their code sitting there. Creates a bigger binaries, more dependency, right? If one of them needs to do, then they still need to sort of create some cherry pick versions and whatnot. We haven't have our cloud provider out there on the GitHub externally. We have it internally. We have work going on to make it available externally. It's the open source side has been already approved internally. So right now it's just work in progress. We should have the cloud provider out there. We're targeting alpha in early 1.16 release cycle of Kubernetes. 1.15 is a short release cycle, I think 3 months only. I'm going to talk more about that later. But with this, it's going to be out of tree. So out of tree is, it's basically loosely coupled now. So all the entry providers, there's this cloud provider SIG I'll be talking about. They are trying to encourage everybody, and everybody agrees to move their code from entry to out tree, so that less binaries they can deal on their own, right? Loosely coupled from the Kubernetes Controller Manager (KCM) architecture. So there's a new architecture called CCM. I'll be talking about that. But SIG also participates in those activities. So there's a SIG Cloud Provider. Anybody familiar with the Cloud Provider SIG? Yeah. So Cloud Provider SIG was created last year, and the main focus right now is two things. The consolidation of individual Cloud Provider SIGs, including SIG IBM Cloud, right? All the Cloud Provider SIGs, we want to be, all of them to be under one umbrella, so that they have stays in better sync and with what they're doing. So I think right now, by July, before around the time for CFP for the next KubeCon in North America, the San Diego one, I think that's the sort of approximate deadline to have this happen. Also, the second thing I said, moving entry provider to out of tree, and that deadline, that's tough work, because people, the clients, users are using it, so those deadlines are, I think they're shooting by end of next year, like, just encouraging folks to the out of tree, not in tree. Cloud provider also by themselves, they adding more code into their out of tree repo and not adding anything in the entry, so that will sort of discourage users to use the entry one. All right, moving next. So IBM Cloud, like I said, Khalid will be providing overview of the public side, private side, and the multi-cloud hybrid side. So to you, Khalid.
Sure. Thanks,
Sure.
Sahdev.
Sure.
So welcome to the SIG session. So I'll give you an overview of these aspects of the IBM Cloud, both the public and private side. A few years back when IBM was looking at Kubernetes, we decided to make Kubernetes kind of a strategic element of our cloud strategy. And we started with the public cloud side, basically being able to let the cloud provider, us, IBM, manage your Kubernetes infrastructure, right? So you don't have to worry about the Kubernetes part, you worry about your application. Then we also, because we have a lot of enterprise customers, they have security requirements and data privacy requirements and so on, we needed an on-premise solution. So that's where we took Kubernetes and packaged that to be able to be deployed in your environment that you manage. So you manage the life cycle of Kubernetes. It gives you that flexibility to configure Kubernetes according to your security requirements and your application needs, and most importantly, probably access data that is in your environment that is not, you don't want to put onto the public side. Thank you. And then, obviously now you have public and private. And not only do you have, just one public cloud, we see, a lot of clients have more than one cloud. There's, reasons that you do that, and we'll get into that. So then how do you bridge all these environments, right? How do you manage all these different Kubernetes environments distributed across multiple clouds and clusters and make them, consistent and conformant and so on. So I'll give you a quick overview of the Kubernetes services. IKS is the IBM public Kubernetes service. As I said, it is a managed service. And it's very mature, right? It's been around for, 3 years almost. And what's more importantly, or what's kind of differentiated about it, is the breadth of workloads that it provides, right? It supports a lot of the, obviously open source tools, as well as IBM middleware. We leverage it for IoT applications. We leverage it for Watson, blockchain, and AI, and all those kinds of workloads run on Kubernetes for IBM, right? And all the middleware that IBM has, especially enterprise middleware, is all in the process, or has been, or is in the process of being containerized and being able to be delivered on the cloud. And this is an important element because it gives you that portability to move between public and private, and public back again, move back and forth between your environments. You might develop your application on the public, but because your data is inside your firewall, then you need to be able to deploy it that way. So the IKS service provides a variety of kind of configurations. You obviously have, a single Kubernetes cluster in one availability zone. You can also take a Kubernetes cluster, and we support multi-zones, right? So you can have workers spread across different zones. So if one availability zone goes down, then the other availability zones also are up and running in order to keep your applications available. Okay. We also support GPU-based Kubernetes environments for AI workloads, for high-performance workloads, and so on. And we support this across the multiple data centers, right, in 6 different regions, over 25 plus data centers. And you can see, in North America, Europe, and South America, and so on, we have regional data centers to support the IKS. So giving you that workload flexibility across, for if you're an enterprise company, you can have, and you have local, data privacy kind of GDPR, or those kinds of requirements, then you can locate your cluster where your applications or where your users are. In terms of the capabilities that we provide, we kind of emphasize the simplicity aspect of it, right? Because we are taking over the process of installing and upgrading and updating your Kubernetes, and you don't have to worry about that, right? You just click a button when you decide to upgrade, and the system will go off and do that. So the simplified cluster management is a key aspect of it. And we give you the flexibility to how you want your cluster to be designed, which zones and which regions, and how many nodes, whether you need GPUs or not, and all those kinds of considerations are there. And obviously, when you're configuring all these, security is important, all the firewall rules, ingress rules, and VLAN stuff that, if you are doing it yourself on the cloud, you have to do all that automation, right, to make sure that everything is configured appropriately. Okay. And then, because, a lot of the, yep.
So what's the interconnect between these systems? What kind of connection do you have? And does it answer some of the HPC requirements?
I think, yeah, we do have fast interconnect. I don't know the exact number. I think at least 10 gigs or 25 gigs within the data centers. I can find out more about that if that's important. I think you're probably more concerned about between the on-premise and the cloud, right? And I think, yeah, I'm not sure exactly the configuration of those data centers, but yeah, I can find that for you. We do have clients running HPC applications in the IBM Cloud. Some of them I think are running on the kind of bare metal servers. Some of them are on the Kubernetes service. Okay. Another aspect, the cluster management is one thing. Then there's all the other management tools that you need, logging, monitoring, and so on. And we provide those capabilities out of box. We leverage certain partners like SysDig and LogDNA to help in that. But you don't have to worry about managing those tools, right? It's all integrated within that. So one of the interesting aspects that came out from the Kubernetes or IKS implementation in the simplified cluster lifecycle management arena, it was announced yesterday, and Brad will talk about it. We open sourced a component called Razzie that allows you to do continuous delivery of clusters, right, within the environment, automatically updates and patches and does all those kinds of things within the for the Kubernetes clusters. So that's a quick overview of the public cloud side, right? And then on the private cloud side, we're taking the same upstream Kubernetes, packaging that together with a bunch of other management tools that you need, like logging, monitoring, security, alerting, etc., all based on CNCF projects, and providing that to clients that want a on-premise Kubernetes environment that they can manage themselves, right? They have full control of how Kubernetes is deployed, which OS it's deployed on, and how Docker is configured, and etc. Right? So it gives you that full control, but it rather than just taking all the open source components and trying to integrate them and making sure that they're all certified and checked and virus scanned and all those kind of security scanning and all those kinds of things, we do that for you. That's kind of the value add of the IBM Cloud Private from that perspective. But ultimately, it's about workloads, right? And we provide a catalog of applications to run, or middleware tools, both open source and IBM middleware tools, to run within this environment. And it supports, sorry, question?
So, I saw a lot of things in your catalog, and my question is, IBM provides support for all of the keys and the middleware in the catalog?
Yeah, so we provide support, obviously, for the IBM middleware, right? For the open source middleware, we provide kind of like community support, right? So we'll look at your issues and triage them and work with the community to fix them.
If I open a service request for MongoDB, for example.
Yeah, so we have partnerships, right, with the open source vendors that are backing those projects to take those requests, right? So, okay. One of the other things I think I didn't mention on the IBM public cloud, right? Beyond Kubernetes, we also provide support for things like Istio and Knative, right? Managed services for that. I should have mentioned that before, but kind of mention it now. And for those things, we also we have Istio and Knative, and also supported on the private cloud side. Okay. Just a little bit of a deeper dive into the architecture of the private cloud solution. So, from the infrastructure point of view, we support all the different types of infrastructure, including Power, Z, as well as x86, and various storage options that the community supports. We automate that deployment. We provide a Terraform-based deployment automation tool for the infrastructure management. And then we support all the container management capabilities, including the image registry and the service mesh and so on. Okay.
About Terraform provider,
Yeah, typically, when you create the cluster, you have to decide between a single node or an HA deployment, right? I think currently the automation tools don't allow you to increase a cluster from 1 to 3, so you have to decide whether it's 3 or 1 when you create the cluster, right? I think scaling the FCD, it's doable, I think, right, with the operator and so on.
Okay.
Right? So that's the capability that we
So
have.
I can do right now through Terraform provider, right?
Yeah, you can do that through a Terraform provider and create. We provide the Terraform, things, and we provide there's a cloud automation manager component that helps in that, right? So you can use that to deploy out your Kubernetes environments. Okay. And then we provide all the other services, things like the logging. We use Elasticsearch and Kibana. The monitoring piece, we use Prometheus and Grafana for that. And the alerting also is under that. And we provide the IBM, we provide a dashboard as well that kind of integrates all these tools together, right? And then, you have we're supporting, a variety of middlewares, whether it's cloud native or containerized middleware, or whether it's for blockchain or app servers and so on, data workloads, and a lot of the DevOps tools like Jenkins and those kinds of things all are enabled on this platform, right? And you can connect out to public cloud service. We support the service broker, open service broker model that allows you to connect to other services that are not running in Kubernetes but want to be consumed by applications running in Kubernetes. So we support, things like even for your existing mainframe environment or things like that. If you want to connect to that and consume services from ZOS or Z-Linux, we support that. For Z-Linux, the IBM Cloud Private can actually run on Z-Linux, right? So we support all the Linuxes. Okay. So that's kind of the private cloud side. Let me talk briefly about the multi-cloud management capabilities. The reality is that you have multiple clusters today, right? You're not just going to have one cluster, even for a small environment, or for you have dev environments, test environments, and production environments. But then there's a lot of considerations around from your application point of view, isolation, right? Multi-tenancy might be one reason for creating multiple clusters, so different lines of businesses don't want to see each other or interfere with each other and so on. You have data considerations, right? So some clusters that have to be separate, right, to meet data residency requirements. Other things like cost, right? Maybe there's certain cloud providers at certain times are providing their infrastructure or their container services at lower cost than others. So you may decide to go with one, but then for a period of time you may run it on another, right? And then load considerations for your applications.
So since you mentioned multi-tenancy part, yesterday I followed the panel,
Mm-hmm.
and there was like a very interesting discussion about
Yeah.
what they want. And before there was a presentation about the multi-tenancy,
Mm-hmm.
where we have this concept of tenant or project
Mm-hmm.
that sits at the top of the namespaces.
Mm-hmm.
And then where we can, and this relation between most of them, we can let the cluster manager just deal with the project part, and the admin of the project or the namespace will just deal with the rest,
Mhm.
set all that, all these kind of things.
Yeah.
And it's quite interesting. That's the approach is going. So what about IBM? Are they taking that in consideration that we might implement that in the future?
Yeah, I think so. Multi-tenancy, like you're on that panel, there's different models for multi-tenancy,
That
right?
part of that model was the most attractive one, and
Yeah.
people they are forcing it because I don't really need to deploy multi-cluster just because I have this concept of tenants. I would like to see that in my cluster.
Yeah. I think that is definitely an item on our roadmap. we are doing work, even the current release, in terms of better supporting. And multi-tenancy is not just about Kubernetes itself, right? There's multi-tenancy for your infrastructure. There's multi-tenancy for your management tools, right? Your logging, monitoring, and so on. So we're doing some of that work to kind of enable that kind of from the end-to-end stack perspective, right? Multi-tenancy, another aspect of multi-tenancy is kind of things like resource allocation between them. So things like quotas and so on. You need some level of delegation of how you distribute those quotas between the different tenants. So those kinds of things we're actively working on. Right? It definitely, in the context of the public cloud, we implemented multi-tenancy in a way. One of the models is kind of running Kubernetes in Kubernetes, right? Where you leverage Kubernetes to spin up the masters of other Kubernetes clusters, right? So that's an effective model that we found on the public cloud side to deal with the scale of clusters. On the public cloud, we have to manage, tens of thousands of clusters, right? And creating masters for each of them. And you can't give them the same API server, right? So two different people can't share the same API server. So you have to have a separate API server for each of them. But then you don't want to provision physical machines or VMs for each of those, right? So you need to find a way of isolating those different tenants, giving them their own API server while saving costs on your hardware as a cloud provider, right? So we have kind of a unique deployment of that, of running Kubernetes masters within a Kubernetes cluster, running the control plane for the clusters that are given to clients in Kubernetes itself. Okay. So for the kind of the bridging between, so we know that the public IBM Cloud is a very good option for Kubernetes, but for a variety of reasons, people are going to pick Amazon or Google and so on, and we want to support that, right? So to provide that capability, we introduced this MultiCloud Management layer, right? This was done last year in the third quarter, I believe, was the first iteration, and we've had a few, 2 or 3 iterations since then. Okay? So today, the MultiCloud Manager allows you to connect and manage Kubernetes clusters wherever they are, right? Be it on your on-premise environment, right? In the IBM Cloud, on Amazon, on Microsoft, or Google, right? We support all those options, right? And you have centralized dashboard and visibility into the utilization of those resources and the details of the underlying Kubernetes resources, and you can search across them, search across multiple clusters to identify problems with your applications, right? It also supports a model, compliance and configuration checking model, where you can ensure that all these clusters are configured according to your specification in terms of network policies, pod security policies, etc. Right? We provide a application model that is an extension of the Kubernetes SIG app capabilities, right? That allows you to create an application which consists of multiple components, right? That can be deployed across different clusters and gives you visibility into those applications by automatically generating Grafana dashboards for the components of those applications and presenting that to the users. And all these capabilities are implemented as extensions to the Kubernetes APIs, right? So they're custom resources that we've added and we're working with the community. We align with whatever's there, and for example, in Kube Federation, we leverage the cluster registry, and then we, to add on certain fields and annotations so that it's compatible with, what other, options that the community is building.
Is this going to use a cluster API sometimes?
Sorry?
Is this going to use a cluster API?
Yeah. We're working, that was one of the reasons to provide the plug-in to the cluster API that we'll get into. So for the process of creating and deleting clusters, we would use the cluster API to do that. And we leverage all the plugins that are in that model. Okay, sure.
When you talk about plugins, you're referring about the clusters, so the piece that interact between
The management plane, yeah.
Okay.
Yeah.
Okay.
Mhm.
We're going to cover that in a little more detail in a couple minutes.
Yeah.
So we'll get rid of it.
Yeah, and the cluster API. So once you have all these clusters and you want to kind of operate and manage and deploy workloads in those environments, one of the other important things we think will come down is the notion of scheduling, right? Scheduling and workload management and so on. So one of the aspects that we have is, in the high performance computing world, there's a lot of scheduling capabilities and resource management capabilities. We're looking at bringing that into Kubernetes, right? And we have an initial version technical preview that allows you to use an HPC scheduler inside Kubernetes as a pod scheduler, right? And you basically get the benefits of some of the policies like fair share and reservation and prioritization in a Kubernetes native way, right? So you don't have to change or modify your applications, and it gives you that capability too. Yep.
So that's really cool. Is it just through the use of annotations?
Yep.
You just add some annotations
Yep.
and then boom, it uses the right scheduler, and then you can do more high performance
Yep.
and stuff.
Yep.
That is really cool.
Yeah, and this is especially useful for GPU workloads, right? So if you want to optimize the use of GPU, the default scheduler in Kubernetes allows you to allocate GPUs on a fairly coarse grain level. Our scheduler extension basically allows sharing of GPUs, switching GPUs between exclusive mode and shared mode, and consideration for memory allocation for the GPUs, etc.
So this means we have different deployment, set,
Yep.
other objects, so it's like a clone of the normal scheduler.
Yeah, yeah. It schedules whatever you identify should be scheduled by that. So in the Kubernetes model, there's a scheduler name field.
Is it separate API server or just an extension like custom versus definition? I don't know.
No, so we did introduce some a custom resource to allow you to specify parallel jobs, right? Because Kubernetes doesn't have the concept of a parallel job where all the pods need to be co-scheduled together, right? And we're working with the other communities like the Kube Batch and so on to say, what this thing should be. But basically, it's exposing, in a Kubernetes native way, the policy engine of the HPC scheduler. Okay. So, what? Go ahead. Sorry.
Will it be available for ICP too? I mean, shared mode for GPU?
It works. It's actually delivered as a Helm chart that can be deployed into an ICP cluster, right? And there's a technical preview out. There's a link kind of hidden down there, right, where you can pointer to it and get access to that. Okay. I think that's. Oh, okay. I don't know why.
What's the next one? Yeah.
Oh, okay.
That's okay.
It's a little slow.
So I clicked it twice. Well, thanks, Khalid. That was great and very good interaction here. So I think that's the whole purpose of this marathon. So it's going good. All right. So quickly, I didn't mention this in the beginning, right? This is a work in progress. Richard Theis, he's actually taking care of this part. As I say, he's not here, but he's working on it. We are with the target of having this be done in alpha open source by July, August time frame. So IBM Cloud Provider interface, that's your interface between Kubernetes and IBM Cloud. And typically, as you know, the cloud provider is a controller, right? That takes care of the things between Kubernetes and the cloud. And all cloud providers have their own provider interface. And this is actually what IKS, the IBM Cloud Kubernetes Service, uses today. And this will be, like I said, will be open source soon. And the advantage will be to the end user in both ways, right? To the existing users who are already using IKS, they don't need to really do anything with this thing, because IKS is taking care of them on this side. However, having it open source, they can always, create any bug they think out there, or any new feature they want to add, or anything out there, right? And the folks who are not using IKS, but they are interested in having their own Kubernetes cluster on IBM Cloud, they can use it. It's mainly right now, the bigger thing is a load balancer. So it manages the virtual IP using keep lived, and two versions out there, IP table based and IPVS based. Instances and zones are.
What has been IPVS?
That's IP virtual server. So that's another way of doing it. Yep, sure. And instance and zones are taken care, from the IBM Cloud side information. And it is a little slow. I was about to click again. So this is the new architecture I mentioned in the beginning of talk, right? So earlier the entry was KCM, the Kubernetes Cloud Control Manager, Kubernetes Control Manager KCM, where the code which you can see here, this is actually the architecture which is on the Kubernetes dock. Only thing we added here is the IBM side. But in tree, everything was under the Kube Control Manager. And, like I said, you community figured out that that's not the way to go, so have everything out of tree. So the only cloud connector point here, as you can see, is a Cloud Control Manager. In tree, everything, most of the thing was under Kube Control Manager, and every node also has certain codes to get the information about node and zone. So that thing is also gone in this new architecture. That's then, like I just mentioned, you have to write. It allows the cloud vendors and Kubernetes code to work independent of each other. There's no dependency there. So so this thing is, as I mentioned, this is work in progress. Because we have it already available internally, it's more work actually. They need to, change their build process and all those things. So we're gonna have things done in iteratively. But that thing is coming soon. With that, this is a pretty interesting sub-project. We should have Brad talk about it.
So very recently, Guanya Liu and his team in China put together, very quickly in fact, a cluster API provider, IBM Cloud. We'll have a link in here, I think, for it. I encourage you all to look at it. The beauty of it is it's still small. I've looked at the code, so it's easy to kind of poke around and kind of learn a lot of stuff. And you'd be surprised how much of the core Kubernetes concepts make their way into this code. CRDs, controllers. It's even used in the new customized stuff, which is how you can, instead of parameterizing templates into your using Helm scripts or what have you, or using your config files, that you can use customized to tweak all the config files. But what the cluster API provider does with this whole approach is everything else in Kubernetes is declarative, right? You got used to all the declarative models. And somebody said, well, you know what? Wouldn't it be great if we had a declarative model for being able to declare how to provision your cluster? So that's what it's filling in. And you're seeing all the cloud providers provide their cluster API provider plugin. And so it's a really neat structure. You've got the main project is the cluster API, and all the cluster API provider projects then pull a lot of the same stuff and use it. So it's like a nice plug-in extension model. And if you basically, you can see how all this works. You're going to have some YAMLs. We'll show here on the thing of what is the declarative describing the cluster. But you've got your target cluster. That's the cluster we intend to create and manage. So you could be creating a cluster in IBM Cloud or AWS or Azure or Google Cloud or VMware. It's a really interesting process, and it's one you got to kind of think to get your head around. There's basically a bootstrap cluster. So there's usually either Minikube or Kind, but you start out with that little small cluster, and from there you're going to create and provision onto the actual target cluster, and then when everything's done, the bootstrap cluster is going to go away. They provide their own community tool, the cluster CTL, and basically it works like all the other CTL tools you're used to. A couple different flags and provide a couple different YAMLs, pass it in, and it's going to take that information and go process it and go create your cluster. And so you can see here, there's different providers. Now, when you go look at the code, the part that is the most interesting, let's see, is it on here? So this is what's neat. You're going to go see there's the main project. You're going to try and learn cluster API. You get a little frustrated, and you're going to look at the cluster API provider. Not as much code there, so it's a little easier to look at. And Brad's going to give you the secret tip. You're going to go find the code that says actuator, because you got all this wonderful structure that's set up so you can get all this cluster control stuff for free and what have you. But if you really want to see how it's ending up doing this stuff and provisioning what's going on, that's going to be in this actuator method that is in the machine controller. So there's your tip. Go look for actuator. You're going to find all the heart of it and then work your way backwards through the code. It's not that bad. It's just a little interesting how the provider code uses some of the stuff from the base project. So it's a little bit kind of funky, but there's not too many CRDs. The controllers aren't too big, and it's kind of a fun project to learn a whole bunch about how Kubernetes works in the small thing of these projects where there's not a lot of code. So I'm going to encourage you, if you want something to go look at it. Go ahead.
So if I understood correctly, the machine control like configure the provider machine actuator talk with the YAS API or VMware API to bootstrap via YAML type machines that are used to deploy Kubernetes cluster.
Yeah, it's going to usually be doing the commands that actually say, hey, I want to get my kube nodes up and running, right? And so what's really interesting is there's all these resources and stuff that they got to move over to your target cluster from the bootstrap cluster, which to me, I still got to get my head around that, right? So you get the bootstrap cluster running, and then there's some resources there, and then it takes care of moving them to your target cluster, in addition to obviously using the actuators to get code up and running. So like on OpenStack, it uses like Gopher or whatever to start up the VMs, and on AWS, it's going to do something to whatever it takes to provision, and our cloud as well, soft layer stuff.
It's kind of democratization about how I deploy a machine in different YAS or provider.
Right, because that's the code that gets really differentiated, right? What does it mean to get something up and running on AWS versus what does it mean to get something running up on IBM Cloud using soft layer APIs, what have you? So that code is kind of where it gets differentiated, but that's really the heart and soul of those actuators. There's two of them. If you want to take a picture, go ahead. That's where you're going to find all the fun code. And then the other stuff is really cool because, like I said, it's Wanya on his team, as you might expect if you know his team and Wanya. This is craftsmanship. He's using all the latest tools that you can find in the Kubernetes community, from Customize and everything else, and the CRDs, and generating the CRDs with Kube Builder. So you want to see sort of the new latest and greatest and stuff. That's why I turned away from Wanya to build something. Go see what he did. That's how you get really smart really fast. So really cool stuff. Go check that out. And then again, here's more of the flow, just in case you're interested. You've got a YAML description of what the machines look like. You've got a YAML description of what you want your cluster to look like. There's also one for the provider components. Those three YAMLs get fed into the cluster control, cluster CTL tool. And from there, they're going to create a bootstrap cluster. It's usually either Minikube or Kind. All that stuff's going to get up and running. Then, step 2, you're going to start requesting stuff on the target cluster. You're going to create a cluster in step 3. And then step 4 is when I talked about the objects that they get up and running in the bootstrap cluster. And I still haven't dug enough deep into this, but it does look very interesting. They move them. This is the standard. VMware and other folks are doing the same way. You move those from the bootstrap cluster to the target cluster, get those up and running, and then you can, at the last step, destroy your bootstrap cluster. Right here, take a picture of this. This is where the code that Guanya's team did is out there. Really cool stuff. I encourage you, let's get some people contributing to it and helping out. Even myself, when I get my copious free time, that's the one I want to go contribute to as well. Very, very cool. And it's still small now. Nothing better than getting in early when something's small, right? And they're still very easy to see, because once these projects in Kubernetes blow up, it's so much harder to go learn it. So come early, folks. So yeah, go check that out. Very, very cool. The other thing we're just going to cover briefly, since it was announced at this conference, is Razzie. No, it's really interesting. Jason pronounced it Razzie. Folks I was talking to, they said they pronounced it Razzie. I don't know. It's one of the two. I better go with Jason and just call it Razzie. But again, our IBM Cloud team has 10,000 active clusters that they manage, right? So at any given time, there's 10,000 active clusters. They got a small team. They are obviously very aware of tools like Jenkins and what have you, but they really felt like they needed their own tools to make this work. Their tools are, what's key with them, obviously designed for scale and management, but it's a pull, let me get this right, pull-based deployment. So the clusters can pull them, and the clusters can self-update, and they also have dynamic inventory. So at any given time, say, well, what's really running on that cluster? So it's easy to know what's running there. They've got dashboards, they've got histories, and they've got ways to control and tailor what's getting sent to different clusters. So the proof is in the pudding. They've got a small team. They're using these tools, using primarily the pull-based deployment as its mechanism to make this work, and having self-updating clusters. And they liked it so much, they made it open source. So they're encouraging folks to go kick the tires. If you have to manage and do multi-cluster deploys for large numbers of clusters, we're hoping people in that community go check it out. So that's really all I'm going to say about that. They're very, very cool that they made that open source and available for the world to use and contribute. That was very kind of them. I think that's all I have. You get to do the summary. You're the boss. Get up there.
Thank you. Boss. Yeah, I mean, this is quick. I guess really not a whole lot here, but we just talk about the SIG, right? It is for leveraging Kubernetes on IBM Cloud, configuring, managing, deploying kind of things, maintaining. Being part of the SIG, following the SIG, you follow the evolution happening in the IKS and ICP side and the MultiCloud Manager from the Kubernetes perspective, and also other CNCF projects, right? SIG and other projects. And we would love folks to contribute. As I mentioned earlier, we have 3 co-chairs. They're all from IBM right now. We would like to diversify the leadership as well. As more people contribute and go up in the ladder. Having diversified leadership will definitely make SIG learn more things, do better in the future. So please contribute. If you're interested, just reach out to any of us on the Slack channel. Can help you get started. And we have now the sub-projects where a lot of interesting things, as Brad explained, on the API provider IBM Cloud side, and then the cloud provider interface. Things which is coming up. With that, thank you, but we still have, you know, we still have 30 more minutes in this marathon, so a lot of time for discussions. If you're interested, yep, please go.
Yeah, I don't know if it's in roadmap, but I think it would be good to have an operator to manage backup, restore, upgrade of the cluster.
If any offers.
An operator that manage this kind of thing, like upgrade the cluster, I don't know.
Yeah, the cluster lifecycle is
Yeah, that's
definitely
life cycle, right.
pillar.
Yeah, because the procedure describing the ref arc in IBM, okay, it's clear, but there are steps. Sometimes people make mistake, so it would be good to have an operator instead to follow the backup, restore, the feature.
I think the cluster API provides the basis of that operator, right? We may need to extend it to all the use cases, like you said, adding and removing nodes from your CPE and those kind of things. So, yeah, the operator model is
Also
definitely.
for ICP.
Yeah, it's intended for,
So
you
it
know, our.
seems, from experience, that the IKS is growing and going faster in every aspect, and the ICP sometimes is slower than the IKS. So it would be good if both teams try to go in
Generally, I mean, that's the distinction between providing something as a managed service and then
yeah.
giving clients control over it. Like for enterprise accounts, they actually don't want change so often, right? They want a stable release and you know, new things over
I
time.
think not only in terms of code or stuff, but best practice on how to properly do stuff, cluster, how to configure. So if you start IKS, you have all the things you need to do. Sometimes, I don't know, many customers don't care about how to use properly an LDAP. Stupid things that can help you to properly segregate all the spaces and the other stuff. So we need this kind of lessons learned things. I think need to be visible on the ICP side.
Yep, I think that's a fair point. Yeah.
And you know, this kind of discussions definitely we can have as part of the SIG as we before. So yeah, bringing all this kind of things to the SIG is really good. You know, that's why I said will help SIG to grow better, right? Yeah. Other like we try to have some discussion points here, but it doesn't have to be one of these. But anything else from here? Yeah. Sure.
In the, I think I'm not sure if next month or a month later, I will start to try ICP mix up with mainframe. So right now I saw documentation is not really clear on how to properly set up the ZMFS side on the mainframe and how to properly interact the open service broker. So I would have some
Sure.
guidance.
Yeah, I think I have some connection with
Okay.
the mainframe team, so just
Yeah.
ping me and I'll try to get you connected and see, get the feedback if the documentation is lacking or functionality is lacking or other things that they're using. So definitely I think help with
You know
that.
how to get how to reach to us, right? Him or any of us, right? With the
Okay, thank you.
Slack or anything. If you don't, I can provide you afterwards. But yeah, it's all on the SIG
The
page.
channel
Yeah.
is the
Slack
channel
channel, the
is,
IBM Cloud,
It's part of
Slack channel.
Kubernetes. Yeah,
okay.
Kubernetes Slack.
I'm on the channel. Okay.
It's like SIG.
The SIG IBM Cloud.
IBM Cloud, yeah,
Amsterdam.
I know, okay.
And the README also has all the three co-chairs contact information there. So
Nice.
yeah, absolutely. So, but yeah, we will take care
Sure.
of it. Yeah.
Okay.
Yes, sir.
Sorry, I have a small question regarding the upgrade strategy. Could you also elaborate if treating Kubernetes clusters as immutable resources is an option? Like for instance, instead of updating the existing cluster, you rather spin out a new one and just use like your federate to move over all the workloads and later on tear it down?
Yeah, the auto scale, if I understood the question correctly, you're talking about auto scaling.
I was
cluster?
No, upgrade, so in
Operators.
when you upgrade from Kubernetes version 1 to 2, right?
Oh, right,
So
yeah,
1.11 to 12, for example.
130 to 140 and a
Yeah. So I think those are the kind of two. There's an in-place upgrade that you can do, right? But you can also do spinning up another one and then, shutting down migrating your applications over and shutting it down. I don't think we have anything that codifies or an operator or something that does that for arbitrary applications. But that's a good idea, I think, right? That, we can
But this is a really interesting discussion because this is what comes up in the cluster API meetings all the time. There's sort of these two camps, right? There's it's kind of simplest if you assume things are immutable, which means it's kind of simplest if I can just treat the machines as things that are going to go away and then I'll start up a new one with a new version. But Khalid, it's sounding like you've already been dealing with what some people call the more complex case, which is, no, I will allow it to be mutable, and I will actually be doing the upgrades in place, if I understood you correctly.
Yeah, the ICP does support an in-place upgrade,
Okay.
but there's restrictions to that.
Okay.
Right? There's gotchas there, right? There's a little bit of downtime when you're for the proxy and so on.
Right. So offline, I definitely want to talk to you because there's a lot of good insights there as the community is looking. Well, they're really scared of that. But it sounds like you're fearless and you've actually found a way to do it in a limited.
I don't think we've done
a lot, but in a contained way, you've made it work.
Right.
So that's kind of cool.
Yeah, in practice, it's a blue-green deployment. I work on the enterprise, and customers don't upgrade that often, right? So they will say, next year we'll go to 1.14, right? And there's the planning. So they do the blue-green, as you said, create the new cluster, and then have an F5 load balancer, so you can put
We also
traffic.
did a proof of concept using Typhoon and the operator SDK using Typhoon to deploy new clusters. Worked quite well.
Okay.
Yeah, but in place,
It's there. I don't
risky,
know.
at least for
Yeah.
customer perspective, they see that as a risky, but it's
There's
improving.
trade-offs
So
there.
if you've done proof of concept, if you want to try it out with IBM Cloud, and if you have any,
Yeah.
if you need any help, we'll be happy to help you out and
The proof of concept has been running in OpenStack. Like we used so Typhoon internally uses Matchbox, which is PVC,
Right.
so to spin up the machine. And we had to provide just with the network access needs the IP. So this was possible. So I don't know how it's gonna run in IBM Cloud.
Another question is, okay, I know ICP to handle SPs as inside its private database. So if I spin a different version and try to drain the pod and push the other pod to the side, there is something to do about this database, or it's just transparent? Is
I
it
think you
just
still
some-
need the storage aspects to
It's
migrate
stateful
over,
or
right?
not stateful. If it's
Yeah.
stateless,
Yeah, the
it's
stateless it works,
crazy,
right?
right? Stateful, you're running a database on
Yeah.
the application.
It's just only
It's more
thing
I mean, that's one reason maybe for some customers that
In place and the storage
may
is
make
attached.
sense, right?
Yeah.
Yeah, because I think about, I don't know, a DB2 installation.
Yeah.
The other aspect of supporting the blue-green is that you need more resources,
Yeah.
right? And you have to spin up for a period of time, double the number of
Right.
resources that you need.
Orchestrate
Sometimes
that.
that's not possible, but depending
Orchestrate
on
the
the cost.
traffic, right? 10%,
Yeah.
20%, you start.
But if I shut down the master node for no time doing my backup of the XCD cluster, the XCD database and the database for ICP, I can do it without quote any risk, right? I can do in place upgrade. So normally what I'm doing is backup the TCD, backup all
Yeah.
the configuration, and the database is used by the ICP for the backup of things. Okay, and then I'm doing the increase.
Yeah, that's what the upgrade of the ICP installer does, right?
So
Backs up
I know there is
ICP.
a risky related to downtime, but the downtime the master.
Master,
Yeah.
yeah. Not your data plane.
Yeah, so my pod is still alive.
Yeah, your own
Yeah.
worker. And in theory, that's how Kubernetes is like. Masters can go for a few minutes. Yeah.
Yeah,
Your
you just
if you try to create a
workloads
plot
can't be
or
deployed,
there's some
or
scheduling,
queries
then
can't be.
it's not going to happen.
Okay.
Oh, well, very good discussions, interaction. Anything, anything else, or I guess if not, then we can call this session. Very good sessions. Thanks everyone again for coming over, having these discussions. Reach out to us for any questions and contributions. Glad to help. So thank you so much.